Welcome back. Good day. We'll be continuing from the previous video. This was all that we discussed in the last video. Now we'll be continuing with the subtopic position, distance, and displacement. Now please do grab your pen and paper so you can take notes. Now, the position of a point in space is determined by its distance and direction from other points. Other points meaning a reference point or a reference frame, which you can call an origin. Now, using the illustration of graph, here we have the y-axis and here we have the x-axis. The y-axis, also known as the ordinates, and x-axis, which can also be referred to as the abscissa. Now, the origin will be somewhere around here at point 0, 0. Now, remember, we're taking our origin in this example as our reference frame. The reference frame isn't fixed. Based on what you're asked to take as your reference frame, that's what you take as your reference frame. Now, in a standard graph, there will be spaces where you can plot your point. So let me try and replicate that here. Now let's take a point S with the coordinates 1, -1, 3. Now plotting -1, 3, -1 will be here and going 3 units up, 1, 2, 3. So point S will be somewhere around here. So this will be S, -1, 3. Now let's plot a point R, -1, 0. -1, 0 will be around here. This is -1, 0, and this is R. Now let's also plot a point Q, 2, 0. This is 1, 2. So Q will be somewhere around here, 2, 0. And finally, let's assume this to be a point P. Let's assume the coordinates of P are not known. Let's call it x1 and y1. Now, you can easily find this from the graph. On the x-axis, we can see it aligns to 2, and tracing into the y-axis, it aligns to 3. So this is 2, 3. Now that's by the way. So this is 2, 3. Now let's join them all, and you'll see what we have is similar to the shape of a square. Now do sketch this and leave this because we're going to use it very soon. Now before we do what I want to use this graph for. Let's talk about a few concepts. First of all, distance. Now, what is distance? Distance is simply length or space between 2 points. So if this is a point A and this is a point B, the length or the space between A and B will be my distance. Let's assume it to be 50 meters. Now, distance is a scalar quantity, meaning it doesn't have direction. Now, let's talk about displacement. Displacement is distance but in a specified or given direction. So when we talk about displacement, we're talking about distance and direction. So you usually see it something like this. Now notice the difference here. I put an arrow signifying direction. That's how you can easily tell a displacement. The arrow shows it's going in a given direction. Well, as of distance here, it's just a straight line. Now, let me quickly illustrate this in a picture frame. Now, assuming we have a hill here and we have a car at this point of the hill. Now, this car will be pointing towards this direction at this point. Let's assume this point to be A, and at this point the car will be pointing in this direction, while at this point we see again the car pointing in this direction. Now we can see the direction is not constant, it's variable. That's why it's a scalar quantity. So this is an example of distance. So let's take this point to be O and let's take this point to be B. So if we ask to calculate the distance from O to B, we'll take the distance, we'll add up distance the car travels, that's the perimeter of the hill. But if we are asked to find the displacement, we'll just simply calculate the length of this line. This will be our displacement because it's in a given direction. Now let's go back to the graph. If we wanted to find the length between S and R, how would we find it? Now we can see the length between S and R will be along the y-axis or the ordinates. And in graph, the coordinates are given in x, y. So we know the position of y is going to be the term that corresponds in this bracket. Now to find the length, we just need to find the change along the y-axis between S and R. And how do we find that? Well, we know the y coordinate of S is 3 and the y coordinate of R is 0. Therefore, SR will be 3 minus 0, and that will be 3. So the length SR is 3. Now let's find the length RQ. Now R and Q are on the X axis, and the X axis is situated in the brackets here. Now Rx is given as -1 and Qx is given as 2. Therefore, the length between R and Q will be the change in length between R and Q on the x-axis, and that's going to be 2 minus 1. That's also 3. Similarly, when you try to find PQ and PS, you'll get similar values. As you can see, the shape here we have is a square, so when you do it right, SR should equal PR and SP should also equal RQ or QR. Now I just want to take out that shape from the graph. So this is our square S, R, Q and P, and we found the length here to be 3. We found the length here to be 3, and we found the length here to be 3 and 3. Now let's assume our starting point is S, and the motion is such a way it goes from S to R, then R to Q, then Q to P, then back to S again. Now let's say we're asked to find the distance SQ, the distance between S and Q, and the displacement of SQ also. Now to find the distance of SQ, it will be 3, that's the distance moving S to R, plus 3, the distance moving R to Q. That is a total of 6 units. Now what if we ask to find the displacement? Remember, displacement is in a given direction. It's a vector quantity. Now the displacement from S to Q will be directly S to Q. It will just be a straight line. Now here's a note: distance is always positive. However, displacement can be positive or negative. Now to find the displacement, looking at SQR, taking out that portion, we have a triangle here. And from Pythagoras theorem, we have SQ to be square root of SR squared plus RQ squared. Now SQ will be equals to the square root of 3 squared plus 3 squared. SQ will equal to the square root of 9 plus 9, which will be equivalent to the square root of 18. And simplifying this, we have about 3 root 2. This will equal 18 is 9 times 2. This simplifies to square root of 9 times square root of 2. Square root of 9 is 3. Then we have root 2 here. Now let's see another way this question could be given. Here we have what appears to be similar to our graph, but now I'm using north, south, east and west. Now let's see the question says, or comes in a way whereby you're using this coordinate system. It could be that it is said a body or a man walks from point S. This would be our point S, assuming this to be our reference S, and goes due south. Now where is south? South is downwards. Due south 3 units to point R. And from the point R, he goes due east. Now from this, we know east is to our right. He goes due east 3 units also to point Q. And from point Q, he moves due north. Now due north is up. He moves due north 3 units to point P, and from P he moves due west. Where's due west? To the left. Now due west 3 units. So this is another way the question could come, and if you could be asked, find the distance from S to Q. Remember, this will sum up this and this to get our distance. If we're asked the displacement, we're going to use this direction here, this line, and use Pythagoras theorem and find our direction, our displacement. Now we're going to look at speed, velocity, and acceleration. So now, starting with speed. What is speed? Speed is simply defined as the rate of change of distance with time. So average speed is given as distance divided by time, and this is equivalent to change in distance divided by change in time. That is final distance minus initial distance divided by final time minus initial time, and it's written as this often. The system international units for speed, SI units for speed, is meter per second, because distance is in meter, time is in second. Now let's represent this graphically. For speed, we're dealing with distance and time. So first of all, we're looking at the distance, time graph. Now for constant or uniform speed in a distance time graph, we're having a straight line. For the constant speed or uniform velocity, we have a straight line. whereas we can also have a velocity time graph, speed meter per second, time graph, time in second. Now uniform or constant speed will be a horizontal line parallel to the x-axis or the time axis here. Why? Let's assume the speed here to be 30 meter per second. If I see the speed is constant or uniform, it means it should be same at every point in the graph, since this is the speed axis. So at this point it's 30, 30, 30, 30, 30. The time intervals may change, the time may change, but the speed when traced up will always give 30. Now moving back to our first graph. Uniform speed is simply when a body covers equal distances in equal time intervals. Now if we are asked to calculate the uniform speed from this graph, it will just simply be the slope of this graph. Assuming this to be D2 and this D1, here T1 and here T2. The slope, which I write as M, will be equal to D2 minus D1 divided by T2 minus T1. Now, uniform speed, I said equal distances. The equal distances I'm referring to is the change, meaning at any point the slope will be same. Any point you take the slope from, it will be same, because the time intervals and the distance, the change in distances will be same. Hence the speed will be uniform in this distance time graph. Already explained here is why in a speed time graph we have a horizontal line, because this means is 30 at any point traced from the time axis up. Now velocity can be simply defined as the rate of change of displacement. So velocity is the rate of change of displacement. Let me take my velocity to be as v. Now velocity is a vector quantity, because remember earlier discussed displacement is also a vector quantity. Instead of distance and velocity, we use displacement. Similarly, velocity, just like speed, has graphs. Now the differences aren't much. Whereas in speed we use distance time graph, but in velocity it's just displacement time graph. So all you need to do there is change the displacement, and in the speed time graph, instead of speed we use velocity time graph. But the shape and the nature of the graphs remain same. So this will be my displacement time graph for uniform or constant velocity, and this will be my velocity time graph for constant or uniform velocity. Now lastly, let's talk about acceleration. Now acceleration is simply rate of increase in velocity. So acceleration, as stated, rate of increase or rate of change of velocity. So change in velocity divided by the time taken for the change. You can also express this as final velocity minus initial velocity divided by final time minus initial time.